So this one.
Mm-hmm.
All right, so let me see what it says. It says, given the table are BMI statistics for random samples of men and women. Assume that the two samples are independent, simple random samples selected from normally distributed populations. And do not assume that the population standard deviations are equal. Complete parts A and B below. Use a 1% significance level for both parts. Okay, so in the table, we see a summary of the sample size for males and females. We see the sample mean for males and females. We see the sample standard deviation for males and females.
Yeah.
Okay. Were you able to get part A?
Yeah.
Okay. Which one was it?
My computer cannot allow me like to go back.
Oh, okay.
Yeah.
Well, let's see if I can do this right now. Assume that the two samples. What I'm doing is I'm reading.
Yeah.
I'm rereading everything. What I'm looking for is the claim.
Yeah.
And actually, I think it's found right here. It says, test the claim that males and females have the same mean body mass index. That's the claim right there.
Yeah.
In particular, males and females have the same BMI. So the question I'm going to ask is, what would that be in symbolic form? How would you say that with the symbols mu1 and mu2?
I would say mu1 equals mu2.
Uh-huh.
Then I would say for hypothesis 1, I would say mu1 is greater than mu2. No, it's less than mu1 is less than mu2.
Why did you say that?
Because when I look at the mean, is 27.2983 for mu1, and the other one is 26.3509 for mu2.
I see. Well, the 27.2 is the sample mean, and the 26.3 is a sample mean.
Oh.
Right?
Yeah.
That's completely separate from the claim.
Okay.
So the claim is not describing the samples.
Okay.
The claim is describing the populations.
Does
that make sense?
Yeah.
And so the claim, when it says male and females have same mean body mass index, they're not talking about the samples. They're talking about all men and all women.
Yeah.
See the difference?
Yeah.
So the claim is what you said, mu1 equals mu2. And you're right. Step 2, what's the opposite of that?
I think it's B, mu1, B.
Yeah, you're right. So mu1 does not equal mu2. Therefore, the alternative hypothesis is the one without an equal sign. The null hypothesis has an equal sign. Okay, now for the test statistic. The test statistic. Now the formula for that, there is a formula for the test statistic, but my recommendation is that you can just use the calculator to do that.
Yeah.
If you forgot, then your green cardstock will remind you.
Okay.
Because this is a question from chapter 9. And there's a lot of information on this page.
Yeah.
The tricky thing, what you got to figure out is where to look for the right instructions.
Yeah.
Right?
Yeah.
So which of these things in boldface, this one and that one and that one, which of those is the best description of this situation?
I think we are looking for the T-claim.
Oh, the test claim?
Yeah.
Oh, okay. Well, we're not there yet. What I'm asking is this a question, is this a claim about one population proportion? Or is this a claim about two population proportions? Or is this claim about one population mean? Or is it a claim about two population means? Is it one population standard deviation? Is it a contingency table for independence?
Mm-hmm.
Those are the, so one of those possibilities
Mm-hmm.
describes this situation.
I would say it's like two population mean.
That's right. You got it right. So two population means is exactly where you want to be looking. And you can tell because we're comparing two
Yeah.
population means, mu1 and mu2.
Mm-hmm.
But it's still kind of tricky though, because you still have to decide. There's still one of three possibilities. We have to reread the question, and you have to decide, are we dealing with matched pairs or are we dealing with unmatched pairs?
Okay.
So what do you think? Are these matched pairs or are they unmatched pairs?
I would say unmatched.
Good. You're right. How did you know?
Because the numbers are not the same, like the samples, deviation, and the mean.
Well, for mine, the numbers are the same.
Mm-hmm.
I mean, the number of numbers in each sample is the same.
Mm-hmm.
But the reason why is because they're not matched pairs, like each male and each female.
Oh,
Like if this was husband and wife,
yeah.
then it would be matched pairs.
Okay.
But if they're not matched pairs, but these are not matched pairs.
Okay.
In fact, you can also tell because it says
Independent.
exactly. So for that reason, you're not going to follow the instructions here.
Yeah.
It's definitely unmatched pairs. So you're either doing this or that. And to decide which one is which, you're going to decide based on whether the population standard deviations are unknown or whether the population standard deviations are known. So we're going to reread the question, but what you're scanning for is any indication as to whether the population standard deviations are unknown or known.
Okay.
Do you see any clues?
Population.
Say again?
No, I'm just trying to look.
Oh, okay.
It's just saying the population standard deviation are equal.
Actually, it says do not assume.
Or do not assume the population standard deviation are equal.
Right. Yeah. Yeah. So I think that implies that we don't know what they are.
Yeah.
Okay. So they are unknown and they are not assumed equal.
Yeah.
Right. And if it's not assumed equal, that means that the samples are not pooled.
Okay.
Okay. So when you reach for your calculator, it's going to ask you whether it's pooled or not. You're going to say no.
Okay.
But if you're trying to test a claim, then you're going to go to this place on your calculator. That makes sense?
Yeah.
Is that what I said? Two
Number
tests?
sample test, yeah.
Okay. So lots of information, data or stats. So data.
Okay, that was what I was telling you. Like on my calculator, when I go to second sample t-test,
Yep.
It's not giving me like the L1 or.
Well, in this case, you would only use L1 and L2 if I gave you the samples.
Okay.
Right?
Yeah.
In this case, you don't have the samples. What you do have are a summary of the samples.
Yeah.
In other words, all these numbers were calculated for you.
Okay.
All right?
Yeah.
So for that reason, instead of going with data, you're going to choose stats.
Okay.
And X1 bar is right there, 27.2983. See if I can make it so I can see everything at once. The sample standard deviation for the first sample is right here. That's 8.8.
867,606.
And the sample size? It's 41. Do you see it?
No.
That's also found on the table. So N is sample size. And X2, so X2 is for females. It's going to be a 26.35. Wow, no music.
Yeah.
Second sample size is 41.
Mm-hmm.
And I think that should be fine. Okay. And then down here, this is where you're trying to put down the alternative hypothesis.
Yeah.
And that's coming from here. This is what, because there's an unequal to symbol right there,
Yeah.
you're going to choose that one. Remember how I said it's going to ask you whether it's pooled or not?
Yeah.
Is it pooled or is it not pooled?
Not.
Right. And then we calculate. So the test statistic is written right here. That's T. We're using the T distribution. And the test statistic is about 0.6099, so on and so forth.
Okay.
0.60. How many? Just 2 decimal places? I guess since there's a 9 after the 0, I should round up.
Yeah.
So I'll change that to
0.61.
61. That's my test statistic. The p-value is
0.54.
That's right. This time they want 3 decimal places.
44.
Yeah. And based on this p-value, at the 1% level of significance, are you going to reject the null or fail to reject the null hypothesis?
I would say reject.
Why? Because it's bigger?
I'm just thinking because the p-value is much higher. Yeah.
Yeah, when the p-value is much higher, that's when you fail to reject the null hypothesis.
Okay.
So I'll draw a picture that'll make it easier for you to remember.
Okay.
So this is my t-axis. And this is my t distribution. Right in the middle of my t distribution is the number 0. And my test statistic of 0.61 is a positive number. So that means it's going to be to the left or the right of 0?
To the right.
Good. So maybe somewhere around here would be 0.61. And that is my test statistic. The p-value, right?
Yeah.
Is the area beyond the test statistic.
Okay.
Now, I'm about to shade this in, but remember, this is a two-tailed test.
Yeah.
So that means the p-value is going to be the area that goes beyond 0.61, but also beyond negative 0.61.
Okay.
See that?
Mm-hmm.
That's because it's a two-tailed test. So the p-value is this area and that area.
Yeah.
And these areas added together, so I'm drawing an arrow here and an arrow here. So together, the area is 0.544. That make sense?
Yeah.
In other words, 54.4%. Okay? The fact that the area is so big means that the test statistic is very close to zero.
Yeah.
And if the test statistic is close to zero, well, does that support the null hypothesis? Or does that fail? Or does that not support the null hypothesis?
Does not support?
Say again?
Does not support?
Actually, well, let me write it this way.
Mm-hmm.
So the null hypothesis written up above says that mu1 equals mu2, right?
Yeah.
That's the same thing as saying that mu1 minus mu2 equals what?
Mu1 minus mu2?
Yeah. If they're equal, what?
0.
Exactly. So because the area was so big, the test statistic was close to zero.
Okay.
And when the test statistic is close to zero, that would support the null hypothesis. Because the null hypothesis says that it should be zero. And this is very close to zero, so that it's not a significant difference away from zero.
Okay.
So it would be a mistake to reject the null hypothesis. We're going to fail to reject the null hypothesis when the p-value is big.
Okay.
So we fail
to reject.
So as I look at my choices,
Yeah.
I can see right away that the correct answer is either A or D.
Yeah.
But you want to make sure you make the right decision for the right reason.
Yeah.
So as you read through these, which one is the right reason to fail to reject the null hypothesis?
I would say A.
There is sufficient evidence to warrant rejection of the claim that men and women have the same mean BMI. Okay. So rejection of the claim, remember mu1 is men.
Yeah.
mu2 is women. mu1 equaling mu2? Are we rejecting that, or are we failing to reject that?
Failing to reject?
Right. You're right. We do not want to reject that.
Yeah.
And in A, it says there is sufficient evidence to warrant rejection of the claim that men and women have the same or equal mean BMI. So it's saying to reject it.
No.
Yeah. What we really want to say is that there is not sufficient evidence
to warrant rejection.
Yeah. Yeah. So I think we're going to fail to reject the null hypothesis for that reason.
Mhm.
Oh, they also want us to construct a confidence interval too?
Yeah.
Okay. Well, in that case, you can see in this same section, it also tells you how to construct.
Construct confidence interval.
Exactly. You just go to a different function.
Mhm.
Let's give that a try. Stat. And then what was it again? 2 sample t int.
2 sample.
So not that one.
Mhm.
I think it's that one, right? 2 sample
With t int.
t interval.
Yeah.
And actually, it's not too much work because all of the numbers that I entered in before are still in there.
Yeah.
This part's different though. What's the confidence level? Anytime you do a confidence interval, you need a confidence level.
Mm.
What do you think?
The confidence interval, the confidence level.
Mm-hmm. I'll give you a hint.
Mm-hmm.
Coming from there.
0.01.
That's the significance level
Mm-hmm.
for a two-tailed test. Therefore, the confidence level should be what?
0.9.
0.90? 90%?
I think 90. Is this supposed to be 95?
No, not 95 in this case.
Oh.
See, in this case,
Oh, are we doing like 1 minus, we minus 100 minus 54.4?
no.
Okay.
Here's your t-axis again, same picture.
Yeah.
But this time what you want to do is to construct a confidence interval for which the bounds would give me the same answer as this test. Now this is that 0.01 is 1%,
Mm-hmm.
okay?
Yeah.
But this is a two-tail test. That means there's a right tail and a left tail. And if we're doing the test at the 1% level of significance, the area of both of these tails together is 1%.
Mm-hmm.
So what's the area of just one tail?
0.01 divided by 2.
That's right. 0.01 divided by 2. This is also 0.01 divided by 2, or 0.005. Which you didn't need to know that, but the confidence level is the
99.
area of this part in the middle. If the area of the two tails together is 1%, what's the area of the middle part?
99.
That's right. That's all you need to know. So when you get to this part right here,
Mm-hmm.
we're going to change that to be 0.99. You see that?
Yeah.
We're going to say that's not pooled for the same reason. And we're ready to calculate. And what you see here is a confidence interval for the difference between the population means. And what I get is negative 3 point, how many digits do I need? I guess 3 decimal places is what's required.
Mm-hmm.
So negative 3.186 and positive 5.081, since they went 3 decimal places.
Yeah.
Yeah,
Mm,
like
okay.
that. So construct the confidence interval suitable for testing the claim. That's going to be, so negative 3.186 and 5.081. Yeah.
Okay.
And once again, the null hypothesis is that the difference is 0.
0.
So based on the confidence interval, do you think that the difference is 0, or is there enough evidence to say that it's not 0?
It's not 0.
Mm-hmm. Well, this confidence interval is telling you what's realistic.
Yeah.
It's realistic that the difference could be as small as negative 3,
Yeah.
or as big as 5. Is 0 between negative 3 and 5?
Yes.
That means that 0 is realistic.
Okay.
So that would support the null hypothesis.
Okay.
You see what I mean?
Yeah.
So does the confidence interval support the conclusion of the test?
Yes.
Yes. Because the confidence interval contains only positive values, only negative values, or contains
0.
0. Yeah. That makes sense?
Yeah.